let understand the differentiability first. Is it? So let take the curve like this. We take a curve like this. Here, take a tangent. Like this. Is it? Let the tangent be at point C. It is point C. Is it? So can you say what will be the coordinate of C here? See, this is point P. What will be the coordinate of P here? See, this is on x-axis and this is, if you draw, what is this? Y. But now y is represented f of x, but this is C, so this will be f of C. Is it? So what will be the coordinate of C? Coordinate of P, C, comma, f of C. Is it? Let's take some small interval of this curve, say here, point B, reduced by some small interval, say h, and take point B, reduce this to a small interval, say by h. Is it? So here, what will be here? Say so this point B, if you say here, it is C plus h, where h is some small interval, and this is, say, this point is C minus h. So what will be the coordinate of B here? At x is C plus h, so it is C plus h, and this is f. Okay, this is f. So what will be here? F C plus h. Okay, what will be the coordinate of A? C minus h, C minus h, comma, f of C minus h. Because this point will be f C minus h, which is equal to y. Is it? Okay, so let's find out the slope of AP. Okay, what is the slope of AP? Is it? What we say here is that y1 minus y2. Is it? y1 minus y2 upon x1 minus x2. We know that the slope of a line how it is defined as y1 minus y2 upon x1 minus x2. Is it? So if we say A here, AP, so what is this? y1 f C minus h. What is y2? F of C. What is x1 upon x2? x1 is what? C minus h, minus of C. Is it? So this C and this C will cancel. So what we will get as f of C minus h minus f of C upon minus h. Is it? This is the slope of AP. Similarly, we have to find the slope of PB. Okay, slope of PB. What is here? Again, y1 minus y2 upon x1 minus x2. What is y1 here? What is y1's f? You say f C plus h minus f of C upon x1. What is x1? C plus h. C plus h minus C. So minus C and plus C cancel out. What we get? F of C plus h minus f of C upon h. Is it? Actually, what we found? We found the slope of AP and slope of PB. But this slope of AP is called LHD. It is LHD. It is LHS means what we say, left hand it is left hand differentiability, and RHD, right hand differentiability. So right hand differentiability and left hand differentiability is nothing but the slope of a line or a slope of a tangent at a point, is it? So differentiability is nothing but the slope of a tangent at a point, is it? So let's define is limit x tend to c minus f of x minus f of c upon x minus c, is it? X minus c. Now the same will reduce it to s tend to 0, some lower interval. The interval is reduced to h, where h is a small interval, is it? So how will write it? Limit x tend to 0, f c minus h, as we did before, c minus h minus f of c, is it, upon c minus h minus of c, is it? This will reduce into limit h tend to 0, f of c minus h minus f of c, okay, this minus and plus c will cancel out, it will be minus h, okay. Then limit x tend to c plus f of x minus f of c upon x minus c is equal to limit s tend to 0, c plus h, f of c plus h minus f of c, c plus h minus c. So this will cancel out, it will be limit h tend to 0, f c plus h minus f of c upon h, is it? So this is the differentiability means, okay. So what is the differentiability means? Differentiability at c, we can write that. This is just for understanding what is actually differentiability means, is it? So if we say differentiability at x is equal to c, then f dash of x, this is common, f dash of x is limit s tend to 0, f of x plus h minus f of x upon h. This is the standard differentiability function, is it? And if we say LDL HD, that is what we defined here, is this one. So we can find it LDH and the limit s tend to 0, f c minus h minus f of c upon minus h, is it? This is LDH, left hand differentiability, is it? Now right hand differentiability is limit s tend to 0, f c plus h minus f of c upon h. If LHD is equal to RHD, is it? LHD is equal to RHD, the function is differentiable, the function is differentiable at x is equal to c, is it? This is the basic definition, okay. This definition will use when left hand limit and right hand limits is defined as same, it is same as we did before, no? For continuous also we are doing, is it? So if this function is used, this formula is used of differentiability when left hand limit and right hand limit are both defined, function is defined as same, is it? Say for instance x plus 2 right hand side, and suppose at x is equal to 2 we say, is it? X is equal to 1, the function is defined as x minus 2 right hand side also and left hand side also x minus 2, then we'll use this function. if this function is defined differently, right hand side and left hand side, then we'll use these two equation, okay, formula, and we'll equate it. When they are equal, then we say that it is a differentiable at x is equal to c. So let's start with the theorem 3, and today you do this theorem 3, then after tomorrow I will start with the exercise or the problem sum based on this theorem 3. Is it okay? So theorem 3, if a function is differentiable at a point c, then it is also continuous at a point at that point. Is it? Means at that point means at c. So let fx be a differentiable at x is equal to c. Okay, what do you mean say the differentiable? Differentiable means they exist infinitely. So then let fx be a differentiable at c means limit x tend to c, f of x minus f of c upon x minus c exit infinitely. Got it? That is differentiable. So let limit x tend to c, f of x minus f of c upon x minus c is equal to f dash of c. This is equation first. Is it? Okay. Again, let the function, if a function is differentiable at point c, so what it means is that let fx be a differentiable at c, then according to definition of differentiability we'll get limit x tend to c, f of x minus f of c upon x minus c is exit infinitely. Is it? So let take that limit x tend to c, f of x minus f of c upon x minus c is equal to f dash of c. Is it? Let it. Now, in order to prove that continuous at x is equal to c, it is sufficient to prove as we did it by the definition of first definition of continuous. Limit x tend to c, f of x is equal to f of c. Is it? So now how to prove it that? Let's see here. Limit what we have? Limit x tend to c, f of x. Is it? Now what we want is here, we want is according to definition f of c. So what we'll write here is that limit x tend to c, f of x minus f of c. Is it? But this was not given, so we'll add it here, f of c. Is it? Now f of c and f of c will cancel, again we'll get f of x, limit x tend to c, f of x. Now what is according to it is there here, limit x tend to c, f of x minus f of c upon x minus c. So here we don't have x minus c, so what I'll do, multiply it and divide it with x minus c. Is it? Okay. Now I will apply the limit on this. So if I apply the limit now, limit x tend to c, f of x minus f of c upon x minus c into limit x tend to c, x minus c. Is it? This will be outside. Is it? This will be outside the bracket plus f of c. Okay. Listen. Here. What is this? If we expand, we know that we have taken this from the equation first as f dash of c. Is it? So limit x tend to c, f of x minus f of c upon x minus c, we taken it, let is equal to f dash of c, so we'll get this as f dash of c into, if we apply limit here c, so c minus c 0, so it will be 0 plus f of c. Is it? 0 into f dash of c is 0, so what we get? F of c. Is it? So according to first definition of continuous, when the limit x tend to c, f of x is equal to f of c, so the function is continuous. So here also we prove that the function is continuous at x is equal to c. Is it? So limit x tend to c, f of x, limit x tend to c, fx, here we want f of c, so I have written minus f of c and plus f of c multiplied and divided with x minus c, is it? Now apply the limit. This is here outside the bracket, here this much. Now apply the limit. So limit x tend to c, f of x minus f of c upon x minus c, is it? X minus c, limit x tend to c, x minus c, f of c. We have taken this as limit x tend to c, f of x minus f of c upon x minus c. We have taken this as here f dash of c. So f dash of c. When we apply limit here, it becomes 0. So f dash of c into 0, is it? Plus f of c. So this is 0 into f dash of c into 0, 0, so f of c. So what we proved finally, limit x tend to c, f of x is equal to f of c. So according to first definition of a continuous, the function is f of x is continuous at x is equal to c. Converse is not true. Okay, you can prove that function is continuous, but it is not necessary it is a differentiable. You know that mod x is always continuous, the mod of x is always continuous. But if you take LHD, okay, LHD will take, and LHRHD will not be equal, is it? Because mod x can be defined as again minus x when x is less than 0 or less than or equal to 0, and is equal to x when x is greater than or equal to 0. So one will get answer minus 1, another will get as answer as plus 1. So function will be continuous at x is equal to 0 we are talking about. But LDH, it will not be differentiable. By using this formula I can say. Okay. Example, I give you that it is example fx is equal to mod x. The converse is not true. Converse is not true means it is a continuous but not differentiable. So here I will show you that how it is not differentiable. Fx is equal to mod x. So D defined that whenever mod x is there is equal to fx is equal to minus x when x is less than or equal to 0, and fx is equal to x when greater than equal to 0 or it's greater than 0. Is it? What we have LDH is limit x tend to 0 f c minus h minus f of c upon minus of h. Is it? Now in place of c, what is here? Where we are checking at x is equal to 0. So this function is defined as at x is equal to c. So in place of c, we write 0 because we are checking the differentiability x is equal to 0. Is it? So put here limit x tend to 0 and put here c as 0. So limit x tend to 0 f 0 minus h minus f of 0 upon minus h. So what you get? Limit x tend to 0 f 0 minus h minus f of 0 upon minus h. Is it? So substitute this function as here. So minus of minus h. In place of x, what you have to write? Minus h, and minus is already there. So minus of minus h. This becomes 0. Minus into minus plus. So limit x tend to 0 h upon minus h. So it gives you minus 1. So LHD is minus 1. Let's see RHD. What is the definition? Limit x tend to 0 f c plus h minus f of c upon h. So in place of c, what you have to write? 0 because we are checking the differentiability x is equal to 0. So put limit x tend to 0 f 0 plus h minus f of 0 upon h. Put in x. It is x greater than 0 is x. So it is h. So limit x tend to 0 h upon h. H upon h is 1. So you can see LDH is not equal to RDH. So function is not differentiable at x is equal to c. Ninth example, f of x is equal to mod x minus 1. Equate x minus 1 is equal to 0, x minus 1 is equal to 0, so x is equal to 1. So how will break up? Okay, is equal to x minus 1 when x is greater than equal to 1, is it? And is minus of x minus 1 when x is less than 1. This is the breakup. Where we have to check the differentiability? We have to check the differentiability x is equal to 1. Means here c is equal to 1. So what we have LDH, LHD is equal to limit h tend to 0 f c minus h f of c upon minus h, isn't it? So what we get? Limit h tend to 0 f. What is this c now? 1. So it is 1 minus h upon f of 1 upon minus h. Where we are talking about LDH, is it? So this will be applicable. Okay, in place of what you have to write? Minus, and place of h what you have to write? X. In place of x what you have to write? 1 minus h. So let it put that limit x tend to 0, is it? F of x. So minus 1 minus h minus 1. What is f of 1? F of 1 is here 0, is it? So f of 1 will be 0. If we substitute 1 here f of 1, is it? Here we are talking 1 minus 1, 0. So it will be minus 0 or 0. Minus of h. Minus h and plus h will cancel out. Minus and minus will be plus. So limit s tend to 0, is it? Minus into minus plus, so h upon minus h, so is equal to minus 1. What is RH? RHD, limit h tend to 0 f c plus h minus f of c upon h. So limit h tend to 0. First, what is your c? You put that. C is, we are checking at 1. So 1 plus h. F of 1 upon h. So limit s tend to 0. F of x is what? Here you see greater than 0. X minus 1. So x is what? 1 plus h. So it will become 1 plus h. 1 plus h minus 1. F of 1 is also 0 here. X minus 1 upon h. So minus 1 plus 1 cancel out. So we'll get limit h tend to 0 h upon h. What is h upon h? 1. So what do you say? LHD is not equal to RHD. So the function is not differentiable, is it? At x is equal to 1.